Teacher Ralph, Teacher Arian. I am very excited for today's episode.
And I can feel
Yes,
it.
I really feel the excitement.
Yes. So, Teacher Liz, what is your topic for today?
Do you see this, Teacher Arian, Teacher Ralph?
Yes, it's a coin. Oh, I think I know Teacher Lee's topic for today's episode. Well, I think it is all about simple probability.
That's correct, Teacher
Oh.
Ralph.
Wow, so what are we waiting for? Let us
Let's
all watch this.
Hi there! Magandang araw! Are you all doing great? Have you done answering your modules? Well, I'm here to help you out. My name is estimating Biopersona, or you could call me Teacher Liz. And welcome to CINEMATEMATIKA for grade A Mathematics. So ready your pen and paper and let's begin. At the end of this episode, you will be able to define probability. Find the probability of a simple event. Solve problems involving probability of simple events. Express appreciation on the importance of probability in real-life setting. Basically, our discussion will be all about probability. Oh, a thunderstorm! Will it rain today? Let me check the weather application of my phone. Oh, 50%. Maybe. This is an example of a scenario wherein an event may occur or not. Another example. Consider which of these events will likely to happen. Number 1. It rains on the first day of school. Number 2. A storm hits the Philippines in January. Number 3. It snows in Panama City. Our personal experiences tell us that rain on the first day of school is highly likely to happen. But storm in January is quite unlikely. Snow in Panama City, on the other hand, is extremely unlikely, right? People use their personal experiences and intuition to answer questions about chances of occurring. But in some cases, it is possible to give a more precise numerical measure of chance, which is known as probability. Probability is the measure of how likely an event is to occur. In mathematics, we can assign numerical value from 0 to 1. The more likely an event is to occur, the higher its probability. The less likely an event is to occur, the lower its probability. Now, let's discuss some terminologies that we will encounter in solving probability of simple events. Experiment. Experiment is any activity performed wherein we arrive at desirable outcomes. It must be a fair experiment where the result is not biased. Outcome. Outcome is the possible result of an experiment. Sample space. Sample space is the set of all possible outcomes. Event is the subset of a sample space. Example. Experiment. Number 1. Mother giving birth. The possible outcome or the sample space, it could be a boy or a girl. Number 2. Flipping a coin. When you flip a coin, the possible outcomes or the sample space could be a head or a tail. Number 3. Rolling a die. When you roll a die, the possible outcomes or the sample space are 1, 2, 3, 4, 5, and 6. Since it has 6 faces. And number 4, drawing a standard deck of cards, the possible outcomes or the sample space is 52. Why 52? A 52 card deck typically consists of 4 suits, namely the heart, the diamonds, spades, and clubs. Each suit contains 30 cards, 10 number cards from 8 to 10, and 3 fixed cards, namely Jack, Queen, and King. Hearts and diamonds are red suits, while clubs and spades are black suits. Now let's proceed to probability of simple events. When we say simple event, that is an event with a single outcome. How are we going to solve that? We are going to use this formula. P of E, or probability of event, is equal to the number of favorable outcomes all over the number of possible outcomes. When we say number of possible outcomes, that is N of E, or we say the outcome. When we say number of possible outcomes, that is N of S, or simply say the sample space. So, in solving probability of simple events, we are going to use the formula P of E is equal to N of E all over N of S. Example. Find the probability of the following events. Number 1, the probability of getting ahead in tossing a coin.
The probability of getting ahead in tossing a coin. The first thing to do is we have to identify the sample space in tossing a coin. In tossing a coin, we have head and tail. Using the formula P of E is equal to N of E all over N of S, our P of E will become P of head. Now let's look for favorable outcomes. In tossing a coin, how many heads are there? We have 1. So our N of E will be 1. Now, what will be our total sample space or possible outcomes? Since our sample space are head and tail, our possible outcomes will be 2. So P of head is equal to 1 over 2, or simply 1/2. So we can say that there is an even chance of getting ahead if we toss a coin. Or we can say that there is an even chance or 50% chance of getting ahead in tossing a coin.
Number 2, when a fair die is thrown, what is the probability of getting A, the number 5, B, an even number, C, a number that is more than 6, and D, a number that is less than 7?
Number 2, when a fair die is thrown, what is the probability of getting letter A, the number 5? First thing to do is we have to identify the sample space. In throwing a fair die, the sample space would be 1, 2, 3, 4, 5, 6. Using the formula P of E is equal to N of E all over N of S, our P of E will become P of 5. Now let's look for our favorable outcomes. How many number 5 are there in our sample space? Correct, we have only 1. So our end of E will be 1, and our end of S, or what will be our total sample space? We have 6. So P of 5 is equal to 1 over 6, or which means there is unlikely chance that in throwing a fair die, we can get number 5. Letter B, an even number. First thing to do is we have to look for the sample space. Again, if we throw a fair die, the sample space will be 1, 2, 3, 4, 5, 6. Using the formula, P of E is equal to N of E all over N of S, our P of E will become P of even numbers. Now let's look for the end of E or favorable outcomes. How many even numbers are there on the sample space? So we have 2, 4, 6. So we have 3. Our end of E is 3. Now, what will be our total possible outcomes? So our possible outcomes will be 6. So P of even number is equal to 3 over 6. Reduce into lowest term, the answer is 1/2. So which means there is an even chance of getting an even number in throwing a fair die. Letter C, a number that is more than 6. Now let's look into the sample space. Our sample space would be 1, 2, 3, 4, 5, 6. Using the formula, P of E is equal to end of E all over end of S, our P of E will become P of more than 6. Now, looking for the favorable outcomes, what will be the number that is more than 6? So based on the sample space, there is none or 0. So we can conclude that it is impossible to get a number more than 6 in throwing a die. Letter D, a number that is less than 7. Let's look into the sample space again. And the sample space is 1, 2, 3, 4, 5, 6. Using the formula, P of E is equal to end of E all over end of S, our P of E would become P of less than 7. Now, looking at the favorable outcomes, what would be a number that is less than 7? So based on the sample space, we have 6. So 1, 2, 3, 4, 5, 6 are numbers that are less than 7. So we can say that our end of E will be 6 all over the total possible outcomes or the sample space, which is 6. So 6 divides 6, the answer is 1. So we can say that, we can conclude that we are certain that there is 100% chance that we can get a number that is less than 7 in throwing a fair die.
Are you still with me? Did you get the concept of solving probability of simple events? Very good! Assessment time! Task number 1. In the word pandemic, what is the probability that the letter chosen is a consonant if one letter is chosen at random? A, 1 over 8, B, 3 over 8, C, 5 over 8, or D, 7 over 8. The correct answer is C, 5 over 8.
In the word pandemic, let's identify first the consonant letters. So how many consonant letters are there? So we have P, N, D, M, C. So we have 5 consonant letters. Now, let's identify the sample space. So how many letters are there in the word pandemic? So we have 1, 2, 3, 4, 5, 6, 7, 8. So our end of S is equal to 8. So using the formula, P of E is equal to end of E all over end of S, our P of E will become P of consonant letters. So based on the given, our end of E is equal to 5 and our end of S is equal to 8. So the correct answer is 5 over 8.
Task number 2. A frontliner will be chosen from a certain group. There are 9 nurses and 8 doctors in that group. What is the probability that the chosen frontliner is a doctor? A. 2 over 17. B. 4 over 17. C. 6 over 17. D. 8 over 17. The correct answer is D. 8 over 17.
First thing to do is we have to look into the sample space. Based on the given, we have there 9 nurses and 8 doctors. So 9 plus 8 is equal to 17. So our sample space would be 17 frontliners. Now, since we are tasked to look into the doctor, our end of E will be 8 doctors. So using the formula, P of E is equal to end of E all over end of S, our P of E will become P of doctor. End of E is 8, end of S is 17. So P of doctor is equal to 8 over 17.
Task number 3. In a school-based virtual quiz bee at Panao City National High School, the winner will receive a smartphone and a load as rewards that they can use for their online class. If there are 2,120 grade 7 students, 2,000 grade 8 students, 1,980 grade 9 students, and 1,900 grade 10 students in the school, what is the probability that the winner will be a grade 8 student? A. 1 over 8. B. 1 over 4. C. 1 half or 1 over 2. D. 1. The correct answer is B. 1 over 4.
Solution. Now, we are going to look for the sample space. So, based on the given, we have 2,120 grade 7 students, 2,000 grade 8 students, 1,980 grade 9 students, and 1,900 grade 10 students. If we are going to add them all, the answer is 8,000. So our total sample space would be 8,000 students. So since we are asked to identify the grade 8 students, so our end of E or favorable outcomes will be grade 8 students. So our end of E is equal to 2,000 since there are 2,000 grade 8 students. So using the formula, P of E is equal to end of E all over end of S, our P of E will become P of grade 8 students. Our end of E is 2,000, our end of S is 8,000. So 2,000 divides 8,000, the answer is 1/4. So we can say that P of grade 8 students is equal to 1/4.
Did you all get the correct answers? Great job! Are you having fun while learning probability of simple events? I really enjoyed being with you, and I hope you feel the same. Again, this is Teacher Liz. See you in our next episode. Stay safe. Bye!